So we're going to review 3 trigonometric functions and introduce 3 more trigonometric functions when it comes to right triangles. The 3 that you've done, you did in geometry. So you'll have to put your geometry hat on to remember them. But we're going to do 3 new ones that you probably haven't seen before. So first things first, we're going to review some parts of a right triangle when it comes to angle theta. So first, this is my right angle, and the side opposite that is called my hypotenuse. But we're specifically going to talk about angle theta. All right, so this is a theta, okay? And we use that a lot in trig to represent an angle inside of a triangle. Whoops, I'm trying to erase it. Give me a second. There we go. Oop, I erased everything. So let's redraw that again. Okay, theta, and the side opposite the right triangle is the hypotenuse. Right? The side opposite theta we call our opposite, and the side attached to theta we call adjacent. And if you remember from from geometry, sine is the ratio of the opposite side to the hypotenuse of angle theta. So if I divide opposite by hypotenuse, we call that sine. When we divide adjacent by hypotenuse, we call that cosine. And for tangent, it's opposite over adjacent. Okay? The way I always remember this was some old horse caught another horse taking oats away. All right, and if you notice, sine opposite of hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Now you're going to learn 3 new ones: cosecant, secant, and cotangent. And these are the reciprocals of the 3 trigonometric functions we already talked about. So cosecant is the reciprocal of sine. So hypotenuse over opposite. Secant is the reciprocal of cosine. So hypotenuse over adjacent. And then finally, cotangent is the reciprocal of tangent. So it's going to be adjacent over opposite. So now what we're going to do next is actually write out some of these ratios to practice using them. Okay. So now we have a right triangle here, and here's theta. So we're going to write out the ratios for the sine, cosine, tangent, cosecant, secant, and cotangent. But the first thing we need to do is to find this missing side here. Okay, so that's going to be the first thing we're going to need to do. So we're going to do that using Pythagorean theorem. So if you remember, Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the 2 legs. So hypotenuse there, sorry, I was trying to erase. All right, and then the legs make an L. So those are my 2 legs, a and b. Okay, so for this one, we're going to have 5 squared because of leg, and we don't know that longest leg, so we're going to put an x, equals c squared, which is 13 squared. All right, so I'm going to have 25 plus x squared equals 13 squared, whoops, which is 169, and we're going to subtract 25 for both sides. So we get x squared equals 144, and so to find x, I'm going to do the square root. So x equals the square root of 144, which is 12. So that's our missing side. Now that we know the side, we can write out the ratios for the 6 trigonometric functions. All right, so we're going to do sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So sine of theta is, remember, some old horse, opposite of our hypotenuse. So if we look at theta up here, opposite's going to be 5, and the hypotenuse is 13. All right, so 5 is opposite theta, so it's going to be 5 over 13, and we would check to see if we can reduce this, which we cannot. Cosine caught another horse, so adjacent of our hypotenuse, is going to be adjacent side, which is the 12. Okay, so the 12 is adjacent because it's attached to theta. Okay, so that's going to be 12 over 13. Remember, 13 is my hypotenuse because it's across from the right angle. So right angle, 13, that's my hypotenuse. All right, and then finally, opposite over adjacent is tangent, which is 5 over 12. Then for cosecant, secant, and cotangent, it's going to be the reciprocals. So hypotenuse over opposite. Hypotenuse is 13, opposite is 5. Hypotenuse over adjacent is secant. So that's going to be 13 over 12. And then finally, cotangent is going to be adjacent over opposite, the reciprocal of tangent, and that's going to be 12 over 5. Okay. So let's do number 2. And I'm going to draw a line here because I, went over. Okay. So we got to find the missing side. This time the missing side is my hypotenuse. Okay, so my hypotenuse is my missing side here. So again, I'm still going to do a squared plus b squared equals c squared, but a and b are my legs. And I'm going to find c squared. So let's see, 12 squared is 144, 16 squared is 256. And then when we add those together, we get 400. And then again, final step, I'm going to do the square root of 400 to get c, which is 20. Okay, so 20 is my hypotenuse. All right, my adjacent side is going to be 12, okay, because it's attached to theta. And then 16 is opposite of theta, so that's going to be my opposite. All right, so we're going to do sine, cosine, tangent, and I always write it like this, sine, cosine, tangent in one column, and then cosecant, secant, and cotangent in another column, probably because that's how I learned it in high school, and so that's why I still do it that way. All right, so sine, opposite of our hypotenuse, remember my hypotenuse is 20, so I know that's going to be in the bottom, and my opposite is 16, and both of those are divisible by 4, so I can reduce that to 4 over 5. Now the next one is adjacent, which is 12 over hypotenuse, which is 20. And again, I can reduce that. Let's see, 12 divided by 4 is 3, 20 divided by 4 is 5. And then finally, tangent is going to be opposite over adjacent. All right, and then both of those reduce as well. 16 divided by 4, 12 divided by 4, and so I get 4/3. And then for cosecant, secant, and cotangent, I can just write the reciprocal. So 5 over 4, 5 over 3, and then 3 over 4. All right, so now I would like you to try number 3 on your own. I would hit pause so you don't see the answers right away, and I'm just going to write them out in a second. So go ahead and pause, try them on your own, and then I want you to check your work. Okay, so you should have hit pause. You should have these done, and I'm going to give you the answer. The missing side is 15. And then let's see, sine of theta, you should have gotten 8 over 17. Cosine of theta, you should have gotten 15 over 17. Tangent of theta, you should have gotten 8 over 15. Cosecant of theta, you should get 17 over 8. Secant of theta, you should get 17 over 15. And cotangent of theta, you should have gotten 15 over 8. Okay. If you didn't get that, and you're not sure why, be sure to ask me. Okay. So now we're going to use information we know about the angle, like if we know the cosine, or we know the sine, or we know the tangent. How can we find one of the other 5 trigonometric functions, or the others? I guess it would be the other 5 since 1 and then 6, whatever. All right, so let's look at number 4. So they say tangent is of angle A is 7 over 12. So I like to draw that out. All right, so here's my little triangle. Okay, so I'm going to put in my missing sides. Let's call this angle A or the acute angle, so they're not the right angle. All right, so let's put in the right angle. And then it says 7 over 12. So if I remember, for tangent is some on horse, kind of other horse taking oats away, is going to be, if I'm going to put angle A here. So opposite is going to be 7 and adjacent is going to be 12. All right, so we need to find cosine of angle A, which we know is some old horse caught another horse adjacent over hypotenuse. So I need to know what the hypotenuse is. So I'm going to do Pythagorean theorem to find that. So a squared plus b squared equals c squared. So let's see, a squared is, let's call that 7. B is the other leg, which is 12 squared, to find the hypotenuse. Okay, so let's see, 49 plus 144, which is 193. So we're going to do square root of 193. I don't think that can be simplified at all. There's not a perfect square that goes into it. Okay, so that's what we're going to use for my hypotenuse. All right, so if I come back up here, actually let's write it down here. Cosine of A equals adjacent, which is 12, over hypotenuse, which is 193. And if you remember from algebra 2, we have to rationalize that. We can't leave a square root at the bottom. So I'm going to multiply top and bottom of this guy by the square root of 193. So I get 12 square roots of 193 over 193. All right, that's the cosine of A. All right, so now we're going to do the inverse of that. I'm going to, I'm given the cosine of A, and I'm going to find tangent of A. So again, I like to draw the triangle. Here we go. Right angle. Cosine is adjacent over hypotenuse. So adjacent to angle A. Let's call this angle A. Adjacent is going to be 1. Hypotenuse is going to be 2. And I wanted a tangent. And for tangent is going to be opposite over adjacent. So I'm going to need to know the opposite. So I got to find this, which is a leg. All right. So a squared plus b squared equals c squared. A squared plus B squared equals C squared. The hypotenuse is 2, a leg is 1. Oops, that should be a plus sign. Alright, so 1 plus B squared equals 4. Subtract 1. B squared equals 3. So B equals the square root of 3. Alright, so tangent of angle A, let's say I got the opposite is square root of 3 over adjacent, which is 1, so just the square root of 3. Alright, so I'd like you to do example 6 on your own. Hit pause, try it on your own, and then I'll give you the answer and you can see if you did it right. Alright, so you should have hit pause, you should have tried it. Alright, you should have all the work shown all in this space. Alright, and what you should have gotten for tangent of B is 3 square roots of 55 over 55. If you didn't get that and you're confused on how to get that, let me know, and I will answer your question for you. Okay, so now we're going to talk about using trigonometric functions to find a missing value. I use tan, cosine, and sine for this. I don't normally use the reciprocal functions to do these because it's easy to find in the calculator. For these, make sure your TI-84 is in degree mode. If you don't remember how to do that, again, ask me, but you go to mode and select degree. And then you use the tangent function to find, or the cosine function, or the sine function to find your missing value. So let me show you how you would do that. So let's look at example 1. They gave me opposite, and they want me to find adjacent. The hypotenuse is not part of this at all. Alright, so if I need to find opposite and adjacent, that is going to be some old horse caught another horse taking oats away. That's going to be tangent. So the tangent of 38 equals opposite over adjacent. Okay? So at this point, whoops, I like to put this guy over 1 and cross multiply. Alright, so 10 equals 1 times 10 is 10. Tangent of 38x. Alright, I'm going to type in tangent of 38. Tangent of 38, when I put that in the calculator, gives me 0. And I'm going to round. Right? And then divide by that decimal. And that will give me my missing side, which I got x is about, because again we rounded, 12.8. Okay, so again, put it over 1 and cross multiply is probably the easiest way to do these. All right, so what did they give you? What do you need to find? That's what I look at when I look at all of these examples. So for the next example, this is my hypotenuse. This is adjacent to my angle. All right, so we look at the angle 63, hypotenuse. Right away, I like to think of it. Did they label the hypotenuse? Yes or no? Yes. So I mark that. Then, is the other angle adjacent or is it opposite? And in this case, it's adjacent. So adjacent and hypotenuse is going to be cosine. So the cosine of my angle equals adjacent over hypotenuse. Again, I like to put it over 1. 4 times 1, because I'm going to cross multiply. Alright, 4 times 1 is 4. X times cosine of 63. Cosine of 63, actually, what I could just do, and you could try it this way too, is just divide by cosine of 63, and you type that into the calculator. So 4 divided by cosine of 63, and when we get that, you should get that x is about 8.8, because we're rounded to the nearest tenth, by the way. Alright, so again, look at them. Is the hypotenuse labeled? Yes or no? Okay, what else is labeled? Opposite, adjacent. Alright, so for number 3, Let's look at it. Is the hypotenuse labeled? Yes. What else is labeled? Well, the angle, the side opposite of 20. All right, so opposite and hypotenuse, that's going to be sine. So sine of 20 equals opposite over hypotenuse. Put it over 1, cross multiply. So x equals 4.5 times cosine of 20. I put that right in the calculator. It gives me x is about 5.0. All right, again, I would type these into the calculator and make sure you're getting the same answers as me to make sure you know how to put it in the calculator. Okay, and finally, we can use the calculator to find the trigonometric ratio of an angle. So we can find the angle now. So now we're going to use the inverse sine, inverse cosine, and inverse tan. That's what these are: inverse sine, inverse cosine, inverse tan. The way you get that in the calculator is you hit second cosine or second tangent or second cosine. Did I say cosine twice? I think I did. Whatever. It's going to be good. You understand what I'm saying. All right? So now we'll use this to find missing angles. So now we look at the angle here and we decide, is the hypotenuse labeled? Yes. What else is labeled? Adjacent. So now I know I'm going to do inverse adjacent hypotenuse is cosine. So inverse cosine of adjacent over hypotenuse, and I type that in the calculator. So second cosine, do the math frac button, will make your life easier. I could just do 4 divided by 7 in parentheses, and I get about 52.2 degrees. Again, make sure your calculator is in degree mode. So now we look at this one. For number 8, is the hypotenuse labeled? Yes. What else is labeled? Adjacent. Oh, it's another cosine. All right, so cosine, inverse cosine of adjacent over hypotenuse. Type that in the calculator. Again, I want you to type it. Make sure you're getting what I'm getting. Tell me if I'm wrong too, because I can fix the video. All right. And then finally, let's look at this one. Is the hypotenuse labeled? Yes. What else is labeled? Opposite. Hypotenuse and opposites could be sine. So inverse sine, opposite over hypotenuse. Type that in the calculator. Second sine, parentheses 4 over 10, parentheses, hit enter, 23.6 degrees. All right, so this has been an intro to the trigonometric functions. You learned a few new ones, okay, and then reviewed some of the old ones from geometry.